Hello, welcome to Presume Technologies. I'm Venkat. This is part 28, Structures in C Sharp. In this session, we'll learn about structs. In part 19 of this video series, we had an introduction to classes, and we have learned that a class can have private fields, public properties, constructors, methods. Just like classes, a struct can also have all of these. Let's look at an example. To create a class, for example, if I want to create a customer class, I use the class keyword. Let's say I want to create a customer structure, then I use a struct keyword and create that customer structure. And then we know that a class can have private fields. Similarly, a structure can also have private fields. Let's say in this example, our customer structure is going to have a private integer field and a private name field, string field. So private int underscore ID and private string underscore name. Okay, and to encapsulate these fields, a class can have properties. Similarly, a structure can also have properties. So to create a property for ID private field, how do we do that? We create a public property. Since ID is an integer field, the property needs to be an integer, and the name of the property may be ID. And then a get accessor, which will just return this dot underscore ID, and we need to have a set accessor as well, which will set the value for ID field. So this underscore ID is equal to value. Okay, so that's the property for the ID field. Now, similarly, we need to create a property for the name field, and to do that we don't have to actually type. We can use the refactoring capabilities of Visual Studio, and to do that you can actually right click on the property, the private field, and select refactor, and then here you can select encapsulate field, and when you click OK, you will get what you want to name the property. It's intelligent enough to give it the same name as that of your field with a capital N, and when you click OK, that's going to give you a preview of how your property is going to look like. So your property is going to look like, has not generated, it's going to generate that for us. So apply, and it has generated that property for us. So this property implements this field, and this property encapsulates this field. Okay, so our structure now has got private fields and public properties. So a class can also have a constructor to initialize the class fields. Similarly, a structure also can have a constructor to initialize this structure fields. Okay, so and we know that a class constructor will have the same name as that of a class. Okay, similarly, a structure constructor will have the same name as that of the structure. So public, and we know that a constructor cannot have a return type. So public customer, and we pass in two parameters into this constructor, which can be used to initialize these two private fields. So int maybe ID and string name. So we use those two parameters to initialize the private fields of the structure. So this dot underscore ID is equal to ID, the parameter that is coming in, and similarly this dot underscore name is equal to the name parameter that's coming into our constructor. Okay, and just like just like how classes can have methods, our structures also can have methods. And let's say I want a method in the structure which can print the customer details. I want this method to be able to print the ID and the name of this customer. So to do that, let's create a public method, public void, and let's call this print details. And what is this method going to do? It's going to print the customer ID and the name. So console.writeLine ID is equal to a placeholder and name is equal to another placeholder. So in the first placeholder, I want to replace that with an ID, and maybe the second placeholder, I want to replace that with a name. Okay, that's it. We have created our structure. Now, if you look at this, it's actually very similar to a class. The only difference that you can spot here is that we are using a struct keyword instead of a class keyword. If it was a class keyword, then it would have been a customer class. Since it's a struct keyword, then this is a customer structure. Now let's see how to use this structure. Now to create an instance of a class, let's say for example I have customer class. To create an instance of this customer class, I will say customer C1 is equal to new customer. And to create an instance of a structure, you follow the exact same syntax. So we have a customer structure here, and to create an instance of that, I say customer C1 is equal to new customer. So here we are creating an instance of a structure. And look at this, we have a constructor for this structure which takes in two parameters, and we use those parameters to initialize these two structure private fields. So let's say my customer's ID is going to be 101 and name is going to be Mark. So we initialize the structure, and if I want to print the details of this customer, I will just say c1.print details, and if we go ahead and run this, it should print the ID and the name of our customer. Now in C# 3.0, they have introduced a new syntax to actually create an instance of your class, and it's called object initializer syntax. Actually, this is one way to create your customer object. Another way is we can say customer C2 is equal to new customer, and we are using the default constructor. Now when I say C2 dot print details, look at what's going to happen. When I run this, C2 customer ID is 0 and name is empty, because why? We have not initialized this customer fields. So let's go ahead and initialize them. And another way of doing it is we can use the public properties that we have created. We know that this customer has an ID public property. So let's say 102. And similarly, it has got a name property. And maybe I want to initialize this to John. Now if we go ahead and run this program, what's going to happen is it's going to print the ID and the name of the second customer as well. What's the difference between these two instantiations? Here we are using that constructor and passing in these two parameters directly into that constructor. And here what we are doing, we are actually using the default constructor, and we are using the properties of the structure to initialize those fields. Okay, and then we are printing the details. Now instead of having so much, you have to create an object, and then again you have to say c2.id, c2.name. What you can do is you can use the object initializer syntax. Okay, so let's create another customer object. Customer c3 is equal to new customer, and a semicolon there, and then you can say id is equal to maybe 103 and name is equal to maybe Rob. Okay, you see that this is much less typing. Rather than creating the object and then using the object dot, you can use this shorthand notation. This is called the object initializer syntax, which has got introduced in C# 3.0. And then as usual, if you want to print the details of third customer, you can say c3.print details. So now we have three customers. Okay, so that's it. So object initializer syntax introduced in C# 3.0 can be used to initialize either a structure or a class. So you can use this object initializer syntax to initialize classes as well. Okay, so far we have looked at the similarities between a structure and a class, but do however keep in mind there are several differences between classes and structures, which we'll be looking at in the next video session. Now, if you look at this example, it's exactly similar to what we have written, okay, but the left one is actually a class, a customer class, and then the right one, it's a customer structure. Now, if you look at the code on the left and compare the left to the right, the only difference that you'll spot is that here you're using the class keyword on the left hand side, and on the right hand side you are using the struct keyword. Other than that, the code is exactly similar. Okay, but however, as I told you, there are several differences. It's very important to know the differences between structure and classes, which we'll be looking at in our next video session. That's it for today. Thank you for listening. Have a great day.